This is an Arduino. You can use it to make a t-shirt that blinks for your best friend's birthday. You can ask a robot to make you a sandwich when you're hungry. You can even make a device that asks all your plants to tweet when they're thirsty so that you don't forget to water them. And you can also make blinds that synchronize with your alarm clock so that when your alarm clock goes off in the morning, it can wake you up. It's pretty cool, huh? Artists, designers, and hobbyists all use Arduino to achieve their purposes. In fact, the Arduino is like the glue that makes stuff work. There's a bunch of documentation on our Arduino website if you need general pointers.
But even if you don't know anything about electronics or microcontrollers, that's okay. Arduino is the friendliest way to start learning about electronics so that you can control them.
Let's start playing with Arduino by making a row of blinking LED lights in our first project. Here are the things that you need. 1. You need an Arduino board. This one is an Arduino Uno. You also need an A to B USB cable. You need some LEDs, and I use 5 in this tutorial. You need a breadboard, and then some wires. You also need the Arduino software, which you can download at arduino.cc. For any Arduino project, there are 2 necessary components, the hardware and the software. Everything you see here is the hardware. For our project, we will start with the hardware part and then progress to the software, and then finally we'll join the two.
This is an LED. It has 2 legs and a body. You may notice that one leg is shorter than the other. The shorter leg goes to ground and the longer leg goes to the positive voltage source. The LED is directional. That means if you accidentally plug the longer leg into the negative voltage source, the circuit is not valid and the LED won't light up.
This is a breadboard. It is very useful for trying out new electronic circuits. Hidden inside the breadboard are many components. If you look at the breadboard this way, the row with the red plus and blue negative signs are linked horizontally in the row. The remaining holes are connected vertically in columns of 5 holes. And there is no link across the horizontal gap in the middle of the breadboard. The Arduino's operating power is 5 volts. There are many components on the Arduino and together they make it a powerful microcontroller. For our blinking light project, we will be focusing on these pins. They are digital pins, which means they can only have 2 states, high and low. For this project, we'll be using pins 8 through 12 and ground. This is a simple schematic of how we will be assembling the hardware. The black wire all the way at the top connects to ground on our Arduino, and the colored wires connect the pins on our Arduino to the power end of the respective LEDs. The assembly process is not difficult. Here's the breadboard the 5 LEDs we'll be using. First, lay the LEDs out like this. The longer leg, the one to power, goes to the left, and the shorter leg, which is the leg to ground, on the right. Now place the LEDs into the small holes on the breadboard like this. Next, we will be placing the wires into the breadboard. The black wires are for ground connections and the colored wires will go to pins on the Arduino for power. Place one end of a black wire in the negative row. That row is connected horizontally and will become grounded. Then get 5 more black wires and put one end in each column, which is connected to the ground leg of an LED. Remember, the columns of 5 holes are connected vertically. Next, we need to connect the other end of these 5 black wires to ground. Since we have dedicated the negative horizontal row to be ground, we can connect each of these 5 wires to any hole on that row. We now need to connect the colored wire to each LED's leg leading to power. Get 5 colored wires and put one in each column, which is connected to a power leg of an LED. Now that we've finished making a circuit on our breadboard, we need to think about which pins these wires connect to on the Arduino. The black wire goes to ground, the red wire here goes to pin 12, the green wire goes to pin 11, the yellow wire goes to pin 10, the green one here goes to pin 9, and the last red one goes to pin 8. Take a moment to locate these pins on your Arduino. Alright, you can go ahead and put these wires into their respective pins. Make sure you connect them to the right ones, otherwise the LEDs won't light up correctly. This concludes the hardware portion of the project. Now let's move on to the software part. Here we write some instructions in code called sketches to tell the Arduino what to do. After you've downloaded the Arduino software, you should open it up and get a screen like this. Setup is called when the sketch starts. It's used to initiate variables, pin modes, start using libraries, and etc. It will only run once, after each power-up or reset of the Arduino board. Here we use setup to configure the mode of each pin. Loop loops consecutively and allows the program to change and respond as it runs. The code in this section runs repeatedly. In this example, we will use loop to continuously turn the LEDs on and off. We will be using pins 8 to 12 to power out the LEDs, so we configure them to be output pins. Now let's move on to the loop section of the code. When a pin is configured to output with pin mode and set to high, it is outputting 5 volts. In this case, the pin will turn the LED on. Then we wait for a second. And now we ride the pin to low, setting it at 0 volts, which turns the LED off. We wait for a second again before lighting the next LED. You see, we repeat these 4 lines of code for the other LEDs, changing the pin number respectively though. The entire code looks like this. Notice that the LEDs behave similarly and most of the code was copy and pasted. As you become more familiar with programming, you will use loops to achieve the same effect. The final step is to upload a sketch onto the Arduino. You need to connect the squarish end of the USB to the Arduino and the other end to the computer. Afterwards, click on the upload button to load the sketch into Arduino. And then look at the lights. You can play around with this example. Say you want the lights to blink faster. You can achieve this by changing the delay value from 1000 milliseconds to 500 milliseconds. The light will blink faster because you told the program to wait for half a second instead of a whole second before turning the LED off again. The Arduino is cool because you can change the software very easily and achieve a responding effect. The Arduino allows you to quickly change something in code to see what different ideas would play out to be. Thank you for watching this tutorial and doing this blinking light project with me. I hope you've had fun and learned a bit at the same time about the Arduino. Thanks, and I'll see you next time.